Ah, screw it, who needs an intro? Haha, hee hee hee, hee 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 ha. Alright, there we are. There we are. Okay, I am back. You see, I went away to have a bit of a rest, and then I realized that I am physically incapable of resting. So I'm back. And so, as such, and so on and so forth. Here's what we're gonna do. I'm gonna open up. I've been just looking at some. Well, at the dark again because of the project. Doesn't matter. So, if you all recall what happened last stream, is it's a funny story. You see, truly comical. Absolutely just chuckle-worthy. It is just heh, heh, ha, and even hee hee. Because let me just switch to live chat from top chat. There we are. That's because this thing right here, which I've been working on for, well, I don't want to say 2 days, but like a solid couple of hours, isn't working. And even worse, we soldered another chip onto it and it didn't work either. So right now I am left with only one choice. Well, at least I suppose a couple, but only one reasonable one. Which is I'm going to desolder all of these wires, which will be a massive pain. I'm going to desolder the chips, which will be a massive pain. And then what I'm going to do is I'm going to set it up properly on the other side. So I'm going to do the exact same setup, but right here. And the difference with the setup is that I will take a lot more care, and I will take all of the... I will first... I also thought about doing it just on a separate board, to be completely honest, just for the sake of cleaning it all up, because it's gonna be a massive mess. But no, this is how we're gonna do it. And then on all of the outputs of the chip, I'm going to actually install LEDs first, to test if it works. And only once it works with LEDs, I'm going to actually plug it into and solder into the components. But before we get there, actually, I would like to note down my progress. You can't see it, but the title of this file is Meow Meow, because this is the taxi video. Yeah, this is the taxi video, and this is the video I would like to work on today, before we actually get to actually doing fun stuff, the stuff I enjoy. You know what they say, if you want to get to stuff you enjoy, you first need to finish your work. And that's what we're going to do today. So, let me just see, because the thing is, in this case, the main thing I'll need to do is describe how the engine works. And in order to describe how the engine works, we will need to watch the best live stream I have had on this channel. When did we start working on it? I'm just gonna have this playing in the background just so that I can... Yeah, explanation of fix it. There's of course a lot there. Alright, first with the theory. What is the idea behind taxi? Well, the idea will be that we need some kind of debug from our fixit. Debug is just a fancy way of saying information, because that's effectively what it is, and then we're just gonna have it on the screen. By the way, I can also test the screen without the SPI divider, which is something I should probably actually do, because I don't need the SPI divider for it. So let's just let's leave the SPI divider for as far down the line as possible. I looked over my other screen and I saw Katsi and I got, my goodness, I got a heart attack for a second. I thought Katsi just joined in the channel without me knowing. But no, it's just the old live stream. Okay, debug is just a fancy way of saying information. If fix it, errors or throws. Hi, the Poncho! How you doing? Even if everything goes according to plan, I'd like. No, which is why. Genius. Okay. We need the debug. And what better way to get the debug than by displaying a colon free on a dedicated screen. Doing well, Father Make It. Surviving school as per usual. Well, first of all, I appreciate you calling me Father Make It and finally showing me some respect, unlike other people I could mention. But second of all, I'm glad that you're surviving. Hey, that's good. Anything interesting happened? Did anything interesting happen? Anything noteworthy? Alright, that's it for the, honestly, the theory behind it, because there isn't much more to say. It's just gonna be a screen. I don't know what else to mention. I don't want to mention too much. The graphical engine, the screen, SPI divider will be interesting on their own. I should have this playing in the background, just to see if anything interesting happens. But okay. We got Archimedes, father of mathematics. Hey, I'm not complaining about you calling me Father Make It. I am in support. I agree. I feel like more people should call me Father Make It. Hey, no argument here. And yes, I did just sadly imply that I'm on the same level as Archimedes. You know. Am I saying I'm better? I'm not saying that. All I'm saying is that Archimedes has never made a graphical engine for rendering colon free. You know, I'm just saying. That's all I'm gonna say. But first, we need to start as simple as we can with a pixel. In this case, we want really how to get that pixel colored a certain way. We'll just say that hardware. We'll just leave it for a future. Make it. For now, our problem becomes how do we. That's what I'm saying, yeah. This is actually one idea I got, because Katsi did mention that they could, if I upload my code to GitHub, they could actually make the faces for Fixit. Or for Taxi, I'm so sorry. Taxi, and this is very complicated when you are trying to personify machines, you know. It does get very complicated because Taxi is a part of Fixit, but in this case, that's kind of like me referring to an organ of a person as a person. Does that make any sense? Am I just drunk? I could be just drunk, I don't know. I have been sniffing quite a lot of lead fumes recently, so that could be it. We might need to initialize a GitHub repo then. Okay. And then anyone could draw their own taxi face. Well, it takes a fair bit of skill to do that sort of thing, because I'm not gonna make any helper tools for it. Why would I? it's my own goddamn code. I don't need helper scripts. No, I haven't checked my email. Oh, I just got another email from. Oh my goodness! I just got an email. Personifying object. Personifying event. That's not that far. I've just gotten an email from a person who I thought ghosted me about a sponsorship. Okay. Now I'm curious. They've ghosted me for like a fucking month. I honestly, I don't know if I should let that slide at this point. I don't think I should let that slide. I'm gonna be skeptical, because back from when monetized make it, heck yeah. Well, let's not get ahead of ourselves, Poncho. This is like the fourth person offering a sponsorship to me. Wait, is it fourth? Okay, hold on. First one had a bullshit deal, bullshit non-compete clause. Second one was a scammer. Third one was for some kind of just also bullshit technology that I didn't like. I think this is the fourth one. So let's not get our hopes up. I have a very... My requirements are pretty high, alright? My standards are really high. Okay, first let's get in it. Initialize empty Git repository, brilliant. Okay, and then I need... Let's see. Public... readme, yes. Alright. Now git remote add origin this. Git commit all the message working taxi. Okay, git add. Okay, git push. Set upstream origin master. Did it work? I have no clue. Let's see. Let's see if it took. Oh, it pushed on master. Fuck, no, that's bad. Made. Okay, fuck it. I guess we're bowling on the master branch. How can I switch the master branch to default? Delete branch. Can I not delete them? You can't delete the default branch. Alright. How can I set the master branch to be the default branch? Git change the default branch. I hope I haven't messed myself up completely already. What's the resettings? Find the default. No, with git config global init default branch name. Thank you, finally. Default branch master. Git push. Can it work? Did it work? I have no clue. It doesn't feel like it worked. Go. Oh my goodness. How have I already messed it up? How have I already messed it up? Right, branches. Default branch from master. Branch master main. Okay, so git branch master main. Okay, git push u origin mine. Fetch first. I would rather not. Git pull. I swear, if it erases everything. No, okay, git push. I've already pulled it. I love technology when it works, but when it doesn't, oh. Can I please have F? Can I just F? Yes, I love technology. Oh, this is brilliant. Problems with the code. No. Oh, Poncho, you have no idea how brilliant this is. So basically, how familiar are you with computers, Poncho? On a scale from 1 to 10, where 1 is being able to turn it on and 10 is making your own operating system, like, where are you vibing? I just need to know how much context I need to do. Because what I did is actually quite comical. Relatively comical. Well, quite comical. I stand by what I said. It's funny. Behind Dunning-Kruger. Well, okay, basically, when you run a command, right? Hold on, I need my paint for this. I always need my paint when explaining things. When you run your command, like for example, I don't know, git, right? Then you have stuff that's called flags. So basically you do like a dash and then you do something. And these flags are basically like your options. Usually H means help. Usually V means verbose, which means that the program is going to tell you a lot more about what it's doing, etc, etc. And another standard is F, which I just used. And the way F works is, F basically means force. And what I just did is I just tried to run a command. It didn't work because it got an error. So I just tried running the exact same command except forcing it to work. And it worked. F basically means I know what I'm doing, fuck off. That's what the F actually stands for those who know. Anyway, the point is right now it works and we have everything. Brilliant. Now, we are going to delete this. We're going to delete this. We're going to delete the loop. And then float consent to whole new ratio, we're gonna set that 0.2. And then if we do WSL, this is not gonna help cats too much. They would need WSL anyway. F is to bypass safety nets, no? Yeah. It means basically, fuck off, I know what I'm doing. That's what F stands for. Now, did I make a build file? I did not. Brilliant. GCC. Did I really not make a build file? That is comical. A real-time graph. Output. Do I need to link anything? I don't think so. I think I'm nailing it. Test. Nope. Obviously we need to link math. Okay, now if we do Python render, you render as a test temp, so this image. What happens if I change this to be minus 0.2? Because I don't really believe I've nailed it perfectly and exactly. Well, that is problematic, unless you are not draw shape. What does draw shape do? Oh, it's been a couple of days, I'm really forgetting everything. Hi there, Lewis, how you doing? Where am I writing to the file? Because I must be... Oh, unless I just should use graph, because I remember... Yeah, okay, we did do backups for specifically that reason. Although this is problematic, Good. Glad to hear you're doing well. I am glad to hear you're doing well. Okay, hold on. I'm gonna play myself some music. Okay. Let's figure out this. Oh, it's because we've been dealing with... I see the problem. Right. We've been trying to use the Schmid. That's what... Okay, so we need to use the graph instead. Okay, graph does not need a loop. Just generally, really does not need a loop. Let's set this to be minus 0.4. There we go! Okay, nailed it. Brilliant. Oh, okay. Hold on. Oh, how monstrous of me, actually. I forgot to write the readme.d. Introduction. How it works. The rendering file is called graph C, and you can figure it out from that. Git add git commits all the message documentation. Git push. Oh, oh my goodness, you are unbelievable. Git add dot git commits all the message documentation. I did it all in Linux, damn it. Git push. What do you mean nothing to commit? What do you mean nothing to commit? That's not a good sign. That is very much a bad sign. Did the readme get through? It did, okay. Brilliant. Beautiful. Alright, documentation basically done. Now. No, I can't go with it. This I'm sorry, but this image, okay, we need to up the ratio a bit, because I can't look at this image. There we go, much better. No, this is not bad. Now what do we do? Well, that's a good question. I liked it before. Oh, you liked it before. Fine. There. I could do it better, I guess. I could do it. I could set it up in a better way, you know. Because what I could do. Wait, does the Python render really not work here? Render py. Right. My goodness. Work with me. I think it does work here. That's good. I could do actually, Poncho, we're gonna need to get someone to make those faces, because there will be a lot of them. If argc is greater than 1, then argv1, 0 will be itself, 1 will be this. Set No wait, no, that's on print. Scanf? I think it might be Scanf. Okay, so it will be Scanf. Oh my goodness, no, because this. No, scanf is inputted by the user, so we don't want scanf. Hold on, we need the scanf family, right? fscanf? I think it might be fscanf that I'm looking for. Yeah, well, by the way, I'm so sorry everyone. I do realize that what I'm doing here is fairly boring, unfortunately. File, no, it's gonna be file. No, damn it. What are you doing, Make It? Well, basically, how should I explain this? How about with a visual? I hope the camera is zoomed in properly. Oh, there it is. This right here is a monitor screen that I am going to attach right here on the front of Fixit. And on that screen, I would like to have a colon-free face that functions as a debug screen. So it's basically letting me know what happens inside Fixit, when it errors, when it works, when it breaks, when it doesn't, and so on and so forth. And right now I'm making a graphical engine for it. That's the deal. C format as floats. There has to be 8 of. String to flow using 8 of. Is that really that simple? That feels way too easy. Feels way too easy. Well, okay. I'm gonna trust you. Tests. And I hope the end doesn't work. That Python 3 render Python. Okay, now let's try to do something like zero control. Yeah! Yes! Look at it! I can control. It lives! Oh my goodness. I can make him sad. Concerned. Or I can make him, well, a face that I don't really enjoy. I do not enjoy this face. It does bother me. Sounds fun. It is a lot of work, and as such, a lot of fun for me. I prefer the evil. Make them back. No, I prefer. No, I prefer evil. I like the evil one. Evil. I think evil is great. By the way, so sorry for the noise in the background. My washing machine is just. Sorry, bothered. Fine. My goodness. Minus 0.45 just for you. Actually, wait, no, we can. I feel like we can nail it to be exactly. This is awful. I hate this. Okay. What am I gonna do now? That's a good question. Well, there are a couple of things I need to do. First things first, we need to make this more efficient. Because so far it's pretty slow. And I don't like that. So in order to figure out how to make this faster, we need to figure out how to do parallelization in C. Yes, programming. Process the program within the system is dependent on the as long as that process thread defines most new person communicate independently. So threads, you see. Threads you say, threads you say. Threads is something I can actually do. Thread function. That's not bad. That is genuinely not bad. That is something I can do. And that could actually speed it up significantly. And if I mess up, I can always just go back in the comment. You can make it evil you want. Evil makes me feel better because I can relate to the evil one. Look at him. Evil. Good. Yes. Yes. Okay, so we introduce a function, takes an arguments. Okay, this is confusing. It's gonna be very confusing. So I should probably separate it off into its own engine, I imagine, for the sake of it not being a complete mess. Yeah. Arc test length. Arc test length 1. Then once you want to tests, actually anything.png would be fine. Yes. Okay. Now, this is going to be awful. But basically we're gonna have engine, let's see, I'm gonna have engine.h, and then in the graph we're going to include engine h, yes. We're going to take all of these away. We're gonna put them in here. We can also put this in. There we go. Alright, now I'm not gonna lie, I would prefer to be working on the board right now rather than this. But oh well, work has to be done. We need to finish the script. In order to finish the script, we need to get through this. So we'll take these. We will also define them right here. Yup. The triangles we can leave. All of these functions we take away and put them in the engine. When we go on to the top, include engine h. And then what we would like is we would like all of these to be defined right here. Okay. Brilliant. Then what we do is we should actually be able to run it just fine right now. Fingers crossed, let's see. If we do GCC graph, then engine C, link muffs output test. You break in the check shape, which means yeah, that makes sense. You break in here because wait, what now? No, you break right here. Yes, that you do. Because, oh, what even is this script? Wait, how did this even work? An arc to shape and the draw shape. Right, let's just comment out the determine color for now, because I honestly don't know what that function does. I don't understand what that function does. Okay, now if we do test and render, does it still work? Okay, brilliant. Halloween is tomorrow. Oh yeah, it is, isn't it? Jeez, I always forget. Unfortunately, I live in the hellish part of the world where we don't celebrate Halloween. Which is unfortunate. I would love to just go out dressed as myself. If I ever have high enough of a budget and am popular enough for this to work, then I definitely do plan on going for Halloween into a more crowded area, just dressed as myself, just for the bit, for the joke, just because it would be funny. Before you say anything, I very much am a horror character. Just look at me. Look at what I do. Okay, now that we have this, what we can do is we can implement the threads. It will be absolutely horrendous. Can't wait for next year. Yeah. Okay, the functions we actually go for is draw shape. Those are the functions that take a long time. So these are the functions we want to optimize. And we do have quite a lot of space for optimizing here. I wonder if it would be faster to draw all of the lines at the same time, or if it would be faster to... Because, yeah, that's basically what we want to do. Let me look at the P threads. So what we want is... creates. That is the first important one, and in this case, we'll create a new thread with attribute specified by attribute in the process. Attribute is no default attribute shall be used. The attribute specified attribute element by later. The thread attribute shall not be inferred. On so completion, if create child stone ID of thread and location of the right thread. Okay. Sole argument singular, which means we're gonna need to pack all of this into a single argument. That's not too bad, because I mean, okay, it's a bit messy. Oh no, because that's what we do. Yeah, okay. Well, it's still a bit messy. Right. I imagine we would like to pass into the threads the pointer. Oh yeah, no, it is a bit messy. But not terrible. Okay. First of all, let's break it apart as much as we can. I think we should do it on a line-by-line basis, so one thread per line. Because otherwise we could do too many threads, and that could actually slow it down. Which means that... Oh, this is painful. Oh, this is painful. This is really, really painful. We make a new function. We call it void draw line, and it will take in a new struct which is line struct. And this line will take in a shape, which will be shape or shap, and then it will take in a void or char pointer, which will be line. Damn it, do I need the size of line as well? Yeah, fine. There we go. Brilliant. So now what we're going to do is we're going to just do a draw line. Temp line is equal to temp line shop is equal to shop, then temp line is equal to really annoying, really annoying, because what we need here is bollocks. I'm fine. Width of the line. This width times I. The 0 then will be gonna be width. Plus 1, width plus 1. Why does width not account for? Make it, you bloody idiot. Plus 1, yeah. And then the address of it. This is a fun code. And then finally, size of line would be equal to, this is a bit arbitrary, so we can just say that width, it's fine. Alright, brilliant. Then we just draw the line with a temp line. And inside the draw line, we're gonna have all of this. We're not gonna have a total index. Oh, really? Okay. I can pull it off. I am clever, I'm smart, I'm amazing, I am unbearably handsome. I'm gonna give myself a yogurt in a moment because I need brain food for this. Or just food. Or a brain. Honestly, any of the three would work. I wouldn't mind either one. Okay. Okay. We draw a line with the line as the input. Oh, once again, annoying because can I just call it line the line data. Line data line. Brilliant. Okay, so we have the line. Then why do I need the size of line actually? That's idiotic. My goodness, what's up with me? This width, right, that's correct. We define this function as well. It's also important. And then in this case, we take that line and line dot line. It's not really line dot line. I am just phenomenal at naming things. J is equal to this. Yeah, right here we need actually check color as a. We need to input color over there somehow. That doesn't really matter all that much. Easier fix. Now line.shape is our shape, which means we can plug all of these in. I by height. That doesn't. Oh, that does matter. Oh, damn it! Unsigned long. Let's do line dex. Because I'm just brilliant at naming things. Line dex. Temp line is equal to temp line dex is equal to well I. Okay, now if I'm not mistaken, this should be width +1, but then not a buffer, obviously, only this. If I'm not mistaken, this should still work in the exact same way so far. Except we already broke it. Not an integer. What do you mean? Oh no! I'm sorry, do you need this? No! Subscript is not an integer. What do you mean? With? That is 400 plus 1, 401 times I, which is also. Why is that a float? What is up with you? Int! Oh, you bloody idiot. Okay, clear. I know why that was an int, but no. I mean, why that was a float. Oh, this won't break. This shouldn't. 3 shouldn't. Okay. 49th line. Line J. What is your problem though? That's a char pointer. That should be fine. Subscript none. It's also a float. You bloody. I know that I. My, this is so annoying. Because then we need to pass it. Oh, that's so annoying. Oh no, that is so annoying. Can I cast it as a float right here? Because I'm not gonna lie. That would help me out. Oh! I hope this works. Okay. Then function draw line. Yup, that's the one we're struggling with. The buffer doesn't exist. That is correct. It does not, in fact. I guess I could have just cast it. Why are we doing line J here? Oh, and that doesn't make any sense. Oh my goodness, it actually worked. Well, worked in quotes, we're about to see. Yes! Oh my goodness, I'm incredible. This is brilliant, because this is effectively... So far I've changed the code without actually changing it, if that makes sense, which it shouldn't. Basically, I have modified the code, but it works in the exact same way. And the reason why I want it to work in the exact same way is because right now we have this function right here. And this function is important because based on it we can create threads, which will make this much faster. Which is something we need because right now it takes like a couple of... Well, you see how long it takes to run. It takes milliseconds. Which sounds fine on paper, or like hundreds of milliseconds. Sounds fine on paper. It's not really good. We'd rather singular milliseconds, ideally microseconds if we could, that would be nice. Because when we're running on Raspberry Pi 5, it's gonna be even slower, so we need to, be careful. How are we gonna do this? We have the draw line, okay. This is the argument we wanna pass in there. Then, we need to create it as an, oh shit. Line D, temp line of height. Can I do this? This is a constant, so it should be fine. And then temp line I. Should work. Temp line I. Is this fine? What did I miss? I managed to get what I wanted to work. But you can't really see anything because I haven't... Yeah. Nothing changes. Yet. We're about to perform something very... I know how annoying it is, by the way. Like, from a visual point of view, it's awful because what I'm doing is actually takes a lot of effort, but you can't see any kind of difference. It's bizarre, it's terrible. Okay. Number of threads, that would be the height. I hope it's fine to do like hundreds of threads. Because there's hundreds of threads. Then we have the thread arguments, which is the temp line. Then what we do is we do rc pthread create. Then we do error checking, which I'm also I would appreciate in this case. And then afterwards we just join the threads. Yes, we have the threads. Okay, in this case, instead of performing work, we're obviously gonna have a draw line, and our thread arguments will be just temp line. Works for the living. You bloody. Where's the number of threads? There it is. What? This time? Yes, RC doesn't exist. That is correct. I messed it up. Sue me if you want. Int. Can I not do it right here? Why can I not do it right here? Just let it go. Oh my goodness. Draw line. Incompatible pointer. Why is that an incompatible pointer? What's your problem? Expected. I freaking love C. Oh, this is brilliant. We had so many others. Bye, bye, Buncher. Bye. Have a good one. I can't see if you're looking forward to that. Good job. Well, I appreciate it. I know I've done a good job. I'm gonna save this image just for in the folder I'm gonna do doing the video, because this error right here. This quite an error. Quite. Oh yeah, I know why the problem is there. By the way, the problem is that this has to be a pointer, which complicates everything. Well, it doesn't complicate everything. Just makes everything more annoying. Because now I need to just change all these dots to lines. No. Still, what is your pro? Oh wait, no. Wait, what? No. What? No. It's because I didn't define it properly. Nope. Draw line, temp line, I. Yeah, because in this case you need the address of the temp line. Oh my goodness, I'm going to lose my mind! Struck line, struck pointer. Yeah, what is your problem then? Expected void pointer pointed void pointer. What do I need to say it as a void? Fine! Fucking fine! I'm gonna cast it as a pointer myself. Input. And then line is equal to... Well, I actually pointer because everything is fucked up. I'm fine, I'm okay, I'm not angry, hey, I'm having a great time, by the way. I'm okay. Oh. Is equal to input, but this... Actually, can I just say it as equal? Can I not do that? And void, obviously, void right here. What? Oh, it has to return a void pointer, is that the problem? I'm going to strangle you. Expected void pointer pointed void pointer, but arguments of type void... Are we looking at the same thing? It's a void pointer, void pointer. What is your problem? There we go, it did work. Okay, brilliant. Does it work? Great question. Oh my goodness! It worked, wow. That is impressive. How long does it take to execute now? Just out of curiosity. See Linux check how long it took to execute. I am curious. Time test with 0.55. Okay, so here are our timings. They remain roughly consistent. I'm just going to screenshot them for the sake of a reference. And then we're going to do the exact same thing, but this time... Oh wait, it's still running drawline. Oh, you bloody idiot. This might not actually have worked. Let's see. Oh, it did work. Thank goodness. I'd like to time it again, please. There we go. Look at that. Oh, beautiful. That's the first optimization. Look at this. Oh my goodness. That is beautiful. Absolutely beautiful. All right. Oh, this is brilliant, I do have to say. I mean, we've just gotten... We have just gotten the threads to work on the first try. I am incredible. I did it on the first try. I have never actually seriously worked with threads. I don't know, I just never... I usually took inefficient programs because I just didn't care. I never had to care about efficiency that much. I just worked on the first try. That was easy. What is going on? Something terrible must be afoot because I don't trust it. First try, yeah, I don't know. And even weirder is that it genuinely seems to be threading because, like, hold on, let me just show you. On the left, this is without threading. And on the right, this is with threading. You can see there is a difference, a significant one even. Well, to be fair, right here we're executing both at the same time, that could be it. Right now it's taking 97 milliseconds. Is that good enough? Well, that means 100 times per second, but on my machine. Yeah. Oh, that's still quite risky. Might be doing the threads inefficiently still. Let's try running the same exact scenario, but this time without the threads. Without the threads it's faster. Damn it! No! It's faster without the threads. No! No! Oh. It's faster without the threads. That is something that could happen actually. But the question now is, did I implement it incorrectly, or is it something that can just happen? Because it can happen if you create too many threads for no reason. Then this would very much absolutely happen. If, however, there could be a golden balance. Because right now we're creating a new thread for each line. That could be genuinely very inefficient. If we pack the lines in groups of something like 50, for example, then that could be more efficient. Ah, oh, dagnabbit. As always, dagnabbit. The problem with packing it is that I've done it in a pretty idiotic way, where basically I need a break line at the end. I mean, if we pack it, the height is 300, so if we pack it in groups of 6, but then we would need to change up the struct anyway. Yeah, line decks normally represented the height at which we were. Unsigned long pack size. And pack size. Let's do it in group of. Could we do 30? Yeah, let's do it in group of 30, so 10 threads. Which means that we do height divided by pack size. And then what we do is right here. We also do pack size. Pack size. Now that we have the pack size, that means right here we know how many more lines do we want to go. So line decks from now on, instead of representing, it has to be line decks. Oh jeez, has to be another for loop. For int I is equal to 0, I is smaller than 9 pack size I plus plus. Yep, and then line decks plus I. This entire thing cast as a float. And will this work? That'll be lovely. It doesn't seem too slow. Holy shit! Oh, oh, but the only question is, does it work? No, damn it. I messed up. Okay, it's fine. Yeah, because line dex has to be multiplied by the pack size. That's the problem. Okay, not terrible, because lindex, whenever lindex is used anywhere, it has to be multiplied by the pack size. Yes. Right, and then right here it should be J. Width plus 1 times I, or I is the height. I times pack size. Okay. Almost indeed, that is true. I am surely missing something. I just need to figure out width plus 1. First of all, this is incorrect. This cannot be line J. I found the problem. This has to be line J plus I times line pack size. There we go. This should do it. No, this should be... Okay, no, this should be I times width plus 1. Right, and then that's I times width. But this should be I times width plus 1 in this case, I think. Oh my goodness, this is awful. Alright. Hey, could be worse, we're getting somewhere. I don't know, I like this look. I do genuinely like this look. Why is this so much better? I do have to say, working on this with Westworld theme in the background is phenomenal. Okay, what is the mistake? J plus I times width plus 1. It could be maybe not plus 1, that could maybe be it. Let's do and test 0.5 and Python 3 render pi. Okay, no, plus 1 certainly does seem. The problem is that we get rectangles. Why do we get rectangles? Why do we only get them sometimes? That is so weird. Right here, this. Oh, okay. This has to apply to all of the lines. Oh my goodness! Oh my goodness, okay. Not bad. Why are the lines on the sides? That could be because I messed up the end lines right here. And I think that's because this has to be actually plus 1 inside, but I has to be plus 1 as well. Oh, I am good at what I do. Come on. I am incredible. There we go. Now we can do the timing. So now we do the timing. We get around 30 milliseconds, which means that we have effectively cut our total time around 5-fold-ish. But if we tweak the pack size a bit, we could maybe end up with something that's a tad more efficient. 20 seems to be better. Okay, 15 is a bit far too much in the other direction. Let's do 20. It seems that 20 is the best. We have to be careful with the pack size though, because if we get a number where the height is not divisible by it, then, well, this entire thing will break. I imagine quite a few errors. There we go, my goodness. Thread thing. Good push. Ah, beautiful. I've done threads. There we go. Let me actually see what it looks like on GitHub. We still have all the PNGs here, which I don't want. I don't want them though. This doesn't appear to be working. Let's remove add.png. What's the opposite of git add then? I don't understand how git ignore works. Never sat well with me. Because you'd think that this removes all the PNG, right? Git ignore templates, let me see. Doesn't matter, see git ignore. Yeah, no, that should remove all the PNG files. Apparently we don't need this either. Git. I don't know how this works. Git ignore just isn't working for me. Whatever, doesn't matter. We've done it. Now we can get back to working the video. Because if we have a screen with a certain amount of pixels and we have the shape, how do we color in these pixels depending on the shape? Classic. So good. My first project. So good that dollars on specialized equipment just to deal with it. What's the next video about? The next video is actually, well, it depends. The next video I'm working on currently is this one right here, so Taxi. But at the same time, I am also working with Remco on the quantum mechanics video. So I don't know which one will exactly come first. With Remco, we first have to do the live stream. And once we do the live stream, that's when I'll really be able to get to work with the quantum mechanics video. On this, I'll be working in the background the entire time. It is possible that next week there will be 2 videos. If I pull myself together, if I actually get to work on them. Fingers crossed, am I right? I'm working on them right now, so that's a good start, am I right? Certainly quite something. Just to deal with it. Okay. So, let's start simple. With the simplest possible shape, and that would be the triangle. Fingers crossed indeed. Okay, when you have a triangle, maybe I should explain the mathematics of how I've gotten this to work. And actually, I'm not going to explain it with Paint because we were planning it with Katsi on this very channel. on a whiteboard, which means that I can just open up the whiteboard. There we go. All right, so this was it. This is the green one is the triangle we've started with. That was the basic idea. In this case, wait, does our... Oh yeah, our engine doesn't work for flat... Does it work for flat lines? I don't remember. I genuinely don't remember if it works for flat lines. Oh, we need to go through all of it in my head in order to figure that out, and I honestly don't care because it's a flat line. Back in, what was the green rectangle? Well, right now, Poncho, I've gotten this to work. On the very beginning, it was executing in 150 milliseconds. Right now, it's executing in 30 milliseconds. So we've basically sped it up 5 times. So that's pretty good. So now that I'm done with this, I'm just scripting the video, and the green rectangle, this is from me planning taxi. This is the planning taxi. This was the planning taxi stream. Okay. The triangle. In this case, like all the pixels to be colored like this. So. Let's start with a simple question. If we have... Actually, we don't need to start a triangle, now that I think about it. Oh, I just got hit with a serious deja vu. Wow. A very serious sense of deja vu. I don't know where from. Oh my goodness, it completely knocked me out of train of thought. I was just picturing in my head, you know what, doesn't matter, irrelevant. It completely knocked me off. That's how powerful it was. Let's have a simple question. If we have a shape, no, it's awful. So, let's start our problem with some kind of simple arbitrary shape. Let's complicate it a bit and a bit more, just for the sake of a challenge. Now, if we select like some kind of point on our board, how do we figure out if that point is inside our shape or outside? In this case, I actually do want to work on the visualizations for it right away. Yeah, you know what, let's open up Blender, why not? Might as well. Oh geez, I'm actually having fun with these fixed videos, can you believe it? Oof. Let me tell you, I don't mean to sound ungrateful, because I am very grateful for the position I am currently in my life in. But one thing I am gonna say is that it's shocking, it's genuinely shocking how much something being your job takes fun out of it. It's genuinely shocking. If you all have some kind of hobbies, the best tip I can give you is to keep them as hobbies, because if you actually start working using those hobbies, that will genuinely take up all the fun out of it. If it's in the hypothetically in the script. Poncho, don't worry, we'll get more to these kinds of videos soon. I'm aiming to do at least one dubiously legal video a month. That's my aim. At least one. We'll see, maybe more. So what we need here is, let's do shape render the ring. All right. Delete this. Keep the volume because the volume is always nice. Yeah, might as well keep it light. Then, what would I like this to look like? Higher, by the way, think, but I know if I said high or not. What would I like it to look like? What do I like it to look like? Well, obviously it's gonna be glowing. That much we can't, yeah, you know. That's not really up to me. But let's just add the typical glowing UV sphere for now as a reference. There. Now what we need to do is we need to make the scene look proper makedy. And I think we all know how to achieve that. So we'll have a chat today. A chat with whomst. With the current president of IEEE USA, really? Oh my goodness, how did that happen? Nobody seems will get make the, you better believe it. Okay. Action create objects, materials, right. We need to pick a good kind of metal. A proper metal. Oh, this is not bad. I like this. Alright, this is what we're gonna use. All you need in order to make a good looking scene is just good textures, and that's it. That is genuinely it. I'll prove it. I mean, look at it, it's so easy. Done. It looks good. Although the roughness is a bit much. There we go. Now texture pack. I paid good money for it. This is where the patron money is going to. The tech, well, it was going to. I don't have the subscription anymore. It's too expensive for me. All right, brilliant start. Where did we go from there? Let's fix it. Definitely. So let's have a so arbitrary shape. You know what? Look at it. Let's think of a challenge. An event that was planned where he was able to meet and give a presentation. Oh, I see. All right, this. Yeah, I'm pretty certain. What kind of event was that actually? I mean, because it does sound pretty neat. It does in fact sound pretty neat. There we go. Oh, dramatic. As I is the Institute of Electrical Engineering if you didn't know, Unholy Fingerbowl, have you seen, unless you were talking to other people on stream, in which case that's fair, but Unholy Fingerbowl, have you seen my most recent video? I very much am familiar with IEEE. Basically the backbone behind, well, modern technology. Without it, internet would be a hellish place. No, just anything engineering-wise would be a hellish place. I don't know, we're all peppering Unholy Fingerbowl with questions. Well, go on, we're waiting. Is that sufficient glow, you'll think? This might be it. There we go. Okay. Shapes, accept, and render the sucker. Just then we'll talk about IEE and what they do and such, as well as some of the stuff is interested in doing research. Ryan, I believe is thing to do with semiconductors. That is vague. Things to do with semiconductors is extremely vague. Well, I suppose present IEE. That's still really neat. That is really, really neat. Rays. So basically, we emit some rays from our point going outwards. Now, we check how many times our rays collide with our shape, and if they collide an even amount of times, that means the shape is outside. If they collide an odd amount of times, means the shape is inside. I can start for a bit of presentation for a bit, so some details are fuzzy. I suppose it's fair. I mean, zoning out during IEEE is honestly quite relatable, and I get that. I was honestly waiting for the free food they were giving out. That's the spirit. That I respect. Oh, what was the food? Was it anything good, or was it just crap? I do have to say, I used to work as like a, well, it was a gig. we didn't really work. It was the gig I did as a camera operator for like one really posh charity event, and the highlight of that entire event wasn't the thing itself. It wasn't the money I got for it. No, it was the free food from the catering service, because it was, you know, one of like, it was the rich people kind of catering service where there was just a whole bunch of tiny plates with like single bite things that had so much flavor in them. It was disgusting, but it was free and I loved it. One of the best moments of my life. It was pretty good. That's good in that case. That's good. Really. If I just rotate this way around, that could... It is pretty easy to see why points on the inside would collide odd number twice, but there is actually a way more important thing to ask here. Computers figure out how many times ray has collided with the shape. Oh, this is kind of low quality. That's not great. Could be worse. Okay, 50 to 90. There we go, beautiful bulbous creation. Absolutely beautiful. Yeah, then I and the present organization showed him our organization's room, and some of the staff was there. That's really neat then, I do have to say. It is sometimes, at least for me, easy to forget that those grand organizations that like determine the standards for the entire world are like made out of actual people. And they actually exist. Not just mythical eldritch runes written before time had a name. So, just emit array going, and if eventually position of array is equal to the position of a certain point on our shape, that means it collides. Right. Well, yeah, but our line, just like our shape, which means that it has an infinite amount of points. Compare the positions of an uncountably infinite amount of points with positions of another uncountably infinite amount of points, it would take quite a long time. I don't think we have enough computation power to compare infinite amount of points with an infinite amount of points. But hey, I could be wrong, what do I know? This, how should I explain this? During a lab, this lab focuses more on RF and EM stuff. I either be put in a project, or if I want, I can do my own research and maybe get a paper published. Oh, that's really neat! Oh, that is really neat. I'm wholly thinkable. I don't mean to be that guy, but if you'd like, eventually you could have your own Discord channel or whatever. Shitty price, I know, but I could use an RF expert. There we go. I want to complicate the shape even more, so 130. I just like catching experts like Pokemon. It's who I am as a person. I'm a hoarder. Alright, let's now complicate it even more by just folding the shape onto itself. Theoretically, the script I'm going to make should work for any arbitrary kind of shape, which is why we should be fine with complicating it as much as we'd like to. Yeah, this should be fine. Honestly, I would have liked to do it a bit more, but yeah, whatever. It's fine. Right. Let's hope the paper gets published. Actually, what are you going to choose, the paper or the project? I see my degree, so I don't have much time. I think I might go for a master's, maybe PhD in a... PhD would be neat. So would be masters. Well, I suppose first master and PhD. Both would be neat. As my completely biased opinion, I think you should do masters. But that is my completely personal biased opinion. Simply from talking with people who are getting a master's degree. Or have gotten a master's degree. No, it feels so cool I can say that. Nice. Let's actually check if gray lights. Okay. Instead, usually do this kind of visualization of these shapes. I'm animating this Blender, which is an extremely sophisticated, I don't want to say advanced, because I mean it is an advanced software, but advanced software will make it sound as if I'm saying that it's advanced as in it needs, you need skills in order to operate it, which is not what I'm saying. Advanced software. So it's easy for Blender to create a ray and figure out if it collides another object. In actuality, shape I've defined, the shape I've created is based on these points. It's either I get put on a project, or if I can think of something to research about and that interests me, then I can do research and maybe get a paper reviewed, published. Do you have any kind of idea? Also, are those two equivalent? As in, do they lead to the same results? Except with one of them you obviously have a paper published. Great Google Doc title. Thank you, I appreciate it. It's on point. What can I say? How will you think about this is what the dog will be about, alright? I don't know what to tell you. Okay. Now what we would like to do is create a point. And here's where the trickiness of it all will come into play. Because we actually do want to... Yeah, oh my goodness, subject info. Point. Because here's better. There we go. Now, if I'm not mistaken, if I do remember correctly, there are actually ways to do rays in geometry nodes. Just stop. You know what? That's it. I'm done. I cannot even with you. Beautiful. I think so. It's just the credit in it. You think so? You mean you think they lead to the same thing, or do you think they don't? Because I honestly already forgot which way I phrased my question. Raycast, yes. Ah, right. How does Raycast work? Source position will definitely be this. Ray direction. We also have a length, which can be smaller. Hit position. Mesh line. Instance on points. Is hit. Set position. Hit position. I don't know if this works. XYZ. Oh yeah, I need to actually instance something on it. Oh, damn it. Right, target geometry. This... Oh my goodness. I am incredible. Okay, but we do want it to... Right. We do want it to go even past the hit. We could also start a little bit further than the hit. Yeah, okay, this is solvable. The point is, it does work. And what we're going to do here is we're going to have vector, or rotate vector. Vector rotate is what I meant, obviously. And then we're going to have this. I'm sorry, why does it reset? Well, that's not great. Rotate vector. What is the difference? I would love to just find out. This one works, the other one doesn't. Brilliant, no, that's great. Instead of doing all of this then, what we would like to do is transform geometry, I imagine. There we go. Neon Kuche, yeah, as always. Okay, now point on our board, which means we'd like this to be 70, and we can delete all of this. That's the board right now. Another project that I'm working on is building a helical antenna for. I don't even know what that word means. Amateur. You mean like an? Oh, is this an alternative spelling of an amateur? Oh my goodness, that is. I don't like that spelling. Amateur satellite communication, I believe. Oh, I see. That is really neat. Satellite communication. That's really cool. How much stuff I'm doing. Yeah. It feels good to be doing stuff, doesn't it? Especially if it's fun stuff. The only points coordinates we know of. Coordinates we know of. My goodness, English really isn't Englishing right now. So how is the coordinates supposed to even? How are we supposed to even figure out the coordinates of the other points along this shape? Well, it's gonna be delicate because advanced. From scratch in C. Okay. Well, that's why we like to actually simplify our scenario a bit. I think I'm talking too much about stuff, but another thing I may have the ability to do, just pop my head. No, you're not talking too much. I'm only thinking, if you weren't talking, then that would just be me working on a video in silence, right? No one wants this. You're good, you're fine. If I wanted to work on a video in complete silence, I wouldn't be streaming. I would just be working on the video in complete silence. No one would make it there. Actually, one of the things I'll have to do is go out shopping soon. Because I don't really have any food. I've ate it all. I've already eaten all my food. Reminds me of the long one. Right, what we could do as well is we could actually color in the point a bit different. Yeah, so we can color the point as in mix color. Oh my goodness, if the entire script for checking if it's inside the shape would have been really convenient by now, but we'll manage. We'll set this to be blue. Yeah. So just do what you want. Exactly. Exactly. Okay, now what we need is we need this right here, keyframes. This to be 1. This to be 1. 0. Okay, it might not be exactly quite as visible as I'd like it to be, but well, happens. One of the possible classes that I may be taking this upcoming spring semester is a semiconductor fabrication class, where for the lab I believe we get to make our own MOSFET from scratch. Goodness gracious me, that sounds awesome. Like, what, are you doing like doping semiconductors there? Because that would be phenomenal. Okay. That's good. Scale of shape. Let's talk about a single line. If we select a point, how can we figure out if our ray will collide with the line? Well, this is still a unnecessary complicated, so let's simplify it further. Let's say that we'd like our ray to be flat. Most likely, that's really neat. Even I haven't opened any semiconductors. Ooh, there's some pretty good deals in the shop near where I live. Oh. As well as chemical etching and stuff, basically all stuff that goes into making it, though I don't know how much we'll actually be able to personally do. probably some stuff we've already done. I mean, obviously, but still, it's quite a lot. It's really neat. Okay. Now, if our break collides with the line is trivial, basically, subdivide our play into 5 segments. Above, the one below, right, the left, and finally the middle. In this case, if our point is over the line or under the line, we know for a fact that our ray will not collide with the line. Loving these last year of undergraduate studies, because that's where all the exciting stuff happens. If you think that's where all the exciting stuff happens, just you wait. I genuinely, once again, I am extremely biased, so if you don't want to listen to me, that's completely fine. I am admitting my extreme bias. But if you think that's where the fun stuff happens, wait till you see Masters. Because I remember, or even beyond Masters, I would say starts, yeah. Masters or even beyond Masters, I can tell you that from my interactions with Flame, it is incredible just how it keeps progressively getting cooler non-stop. Right line. If our point is on the left, same thing goes for our point is on the right. The point is right. We finally get a guaranteed collision, but what about the middle? Well, that's a brilliant question. What about the middle? Okay, this I do. I'm working on this video like crazy. Actually, now I think about it, because I mean, to be fair, the practical part of the project I only finished the graphical engine. But the SPI divider I already have fully designed. That one I just have to make. Which, yeah, a lot of effort, but, you know, not a lot of mental effort. Something I should be able to pull off. The screen itself would just require a bit of research and a bit of banging my head against the wall, but at the same time, I imagine all of the datasheets should be quite descriptive. They have been in the past for smaller modules, and usually the bigger the module, the more descriptive and digestible the datasheet is. At least that's what I found. So we are genuinely going crazy. In the middle, our ray can collide like also, with how exciting this stuff is, and much I want to talk about. It's funny how people have conspiracy theories of scientists lying, keeping stuff secret, when we know. That's what I'm saying, right? It's what interests you. You'll be stuck for hours listening to them talk about it. That is what I'm saying. Okay. This all is really cool. I can't wait until we get into even more like cutting edge, because then they'll be even more fun. You do seem very passionate, so I genuinely feel like you will enjoy advanced science or advanced engineering. Same difference. I don't care. Well, enter delete computer science, because we've just entered the planning stage of the actual script, which means that this will just mouse. Now, we'll put everything I say on screen as equations, but don't get spooked. They will be equivalent to what I'm saying. They're just there to solidify and specify what I'm talking about. So for example, if I function and I say for example, if I say that we'd like to know, what do you think, make it, is the best technology? That is extremely vague and open to interpretation question. Oh, first of all, that is the best. Okay, it's an extremely vague question, so it's I won't exactly defend my point on this too much, but I do believe that could be electricity. I don't know if you would classify that as technology, but the thing is, the more you research about electricity, the more you realized how, if you were in the 18th century and you were designing machines using cogs and wheels and tapes and such, then if you had to, like, if you were in the 1800s, if you were designing machines using mechanical parts, and if you find a genie's lamp and could wish for a perfect thing in order to create machines, you would basically create electricity. Engineering is applied physics. That's physics theoretical engineering. I'll be brutally honest with you, unwholly thinkable. A lot of people around me, mainly because, you know, it's the internet, so obviously, a lot of people around me always try to grab me into the whole debate, engineering versus science. But I never got it. I don't understand. What is the... Where do you draw the line between engineering and science? Like, because if you're dividing the line based on theory, that would be the most accurate, I suppose. But then designing circuits would be science, whilst building them would be engineering. That's a very arbitrary division. Cryptography, science or engineering? Large Hadron Collider. What, the purpose scientific, but the build engineered? What about operating the Large Hadron Collider? Is the Large Hadron Collider operated by engineers or scientists? I never got it. I just find the statement funny. I mean, yeah, it is pretty good. I feel like that's a statement that a lot of physicists would really like. Lord knows Remco would love that. Okay, there we go. Where are we? Scripts. Oh my goodness, we're already on 3 pages, jeez. Using rays. So basically we made some kind of rays from a point going outwards. Now we check how many times our rays collide with our shape. And if they collide an even amount of times, that means the shape is outside. Oh, that's going to be annoying. It's going to be really annoying. Let's make that 10 pages. That will actually probably be around the length of the normal video. Let me actually see, how long was the last one? It's called untitled document because I never cared enough to actually call it anything. The first two are just code. Oh yeah, the last one was 7 pages. Well, no, 6 pages. But to be fair, the last one was pretty shite. I didn't like the last video quite as much as I thought I would. I kind of lost the steam at the end though, unfortunately. With this one I hopefully will carry through it. Some rays from going out. Okay, let's just try with a single ray for now. And in order to do a single ray, all we do is this. But crucially, we also do a cylinder or mesh line. My goodness, make it. We don't live in the Middle Ages anymore. You can just use a mesh line. And then value right here. Vector math scale is vector by value, ray length. And then end location, start location. Mesh to curve, then U. Why is it misaligned? It so very much should not be misaligned. Oh, what now? Why? Just why? Just genuinely why? Don't tell me you're colliding with yourself because that doesn't make any sense. This is geometry you should be colliding with. That geometry has nothing to do... Oh no, because the ray length is so short. Oh, right, no, that checks out. Okay, I'm an idiot. But I'm not crazy, it's not going through the middle of the icosphere. Because it collides first with... Oh. Yeah. Which means that in order to make this better, more accurate, we would like to actually make this a bit smaller. Can't do 0 because they will never collide. 0, 1. Yes, but the issue is that if it collides, oh goodness gracious me, right here it should be instant on points, right? Which means that instead of this, we like the instance. Let's do 2 for now. Set position. Right, but this should hit it twice. I'm okay. I'm okay. I'm okay. I can crack this bitch. I can figure this out. It's fine. Sample attributes or attributes, capture attributes. No, not capture attribute. Attributes. Named attribute, but there was like a based on an index. Index. Sample index? Oh, I think it might have been sample index. Okay. Now, if I'm not mistaken, we don't have any geometry to give it. But if we do index, so if we do this, then this as set position. I'm fine. Okay. Nothing like dealing with Blender memory types. Blender raycast. How do you even? Yes, raycast node. For each ray as a target geometry. Oh, does it work on a... No. For each ray. Oh. Fudge sticks. That's not great. Yeah, no, we need to do it completely differently. The ray length would have to be way longer, and what we would actually need to do is, we'll keep the ray direct, we'll keep the source. You don't instant point, don't send position, because that's a waste. Instead, transform geometry, light, icosphere. Okay, instead, we need to take all of this. Ideally, package it up into a make group. Yeah. Then, repeat zone. It would be really great if there's a while loop. Repeat. No. Okay. We need to do it with constant repetition then. And then what we do is we just do this, we do the standard setup for repeat zone. Now basically the way we do it is simple. We have this. This right here basically gives us the ray direction, source position. Source position will go in here. And that will be the start location. Also the source position, yes. Then hit position will go to the end. And then this will go in right here. Oh, why did you go back? No. Damn it. Just to simplify it a bit, because we don't need to complicate it that much. We can remove the mesh line. Okay, so this is what we've got so far. Now, why isn't this working? Because we lack direction. Yes. Damn it. Why? Ah, because it has to be vector math, and then we need to add to, no, we need to scale it? No, add to it the direction scaled by a small value. .01. Okay, 0.05. Yes! Okay, my goodness. And then switch. No, switch. Just switch on its own, and then this hits. Beautiful. Oh my goodness, I've done it. Okay, now we can just repeat it however... Well, no, we cannot repeat it however many times we like, because it breaks. Okay. So we need switch. Actually, this switch we'd like right here. I think this can be it. And then we can set it like 10. Why do you keep going? Ah, because it's hit, there should be no. If that should be no, then that would mean switch vector. This only if it's hit. If it isn't hit, that means... Okay, let's... I can do it. I'm a programmer. Should be easy to me. This should be easy. Boolean math. This has to be a not. This has to go to false. Then, this has to be or. Itself. Right? No, this has to go in there. There we go. My goodness, I'm good at what I do. There we are. Now we can rotate it around, and this gives us all the rays we could ever wish for. Oh, I'm good at what I do. Brilliant. Okay, let's have it be 90, just for the sake of keeping it simple for now. Raise indeed, raise indeed. Afterwards, no check how many times or its color shape. And what's even better is that this should genuinely work for any arbitrary position. Oh my goodness, I'm good at what I do. Alright, I am good at what I do. Let's set the brightness of our icosphere to like 20. Let's keep it at a nice 1.6. And let's keep the brightness of a curve at something like 3 or 4. There we go. Right, this is good. Yeah. What happens if it doesn't collide at all? Do we just get an infinite line? Or do we not get a line at all? We don't get a line at all. Ah, brilliant. I hope the glow isn't too much. Well, there isn't any text, so it should be fine. Okay, you know what, everyone? I think that'll be it, because I need to go to the shops and buy myself some food, if you don't mind. This was a good stream. We have gotten a crazy lot of work done. We started by parallelizing the taxi engine. Then we went on to script a pretty big chunk of the video, and we've also started rendering, which actually, that's pretty good progress, because usually getting started on the video is what takes so much, you know, effort. Anyway. That was neat. It was really lovely talking to you all. Poncho around the unholy thinkable. It was great. But all good things eventually must come to an end. And as such, I leave you. Thank you, everyone, so much for watching, and have a great day.